Good evening, everyone. Thank you for coming to a short talk this afternoon. My name is Paul Beasly, and I'm a product manager with Maincomp. And today I'll be discussing and talking about how Maincomp is leading the commercialization of gallium nitride for power amplifier applications. And I'll be talking about three main points today. The first is a brief overview of the GaN landscape and how that's evolving, and how gallium nitride is a disruptive technology that allows our customers to achieve new levels of performance in terms of size, weight, and power. Secondly, I'll be presenting our latest and greatest released GaN in plastic power transistors, which further enable our customers to achieve significant benefits in their systems in terms of size, weight, and power. And the third thing that I'll present is how that technology platform can be leveraged to introduce and promote further future technologies that are more highly integrated solutions. So to begin with, I'd like to introduce some of the market segments which can benefit from gallium nitride. And all of these market segments are areas where Maincomp has worked in for a very long time and supported with power technologies, such as weather radar, including the multi-phase array radar system for weather radar, paved pause, which is for surveillance, defense requirements, data links, marine radar, air traffic control, and satellite communications. And all of these market segments are continuously looking for ways to challenge the system requirements to shrink the size, reduce the weight, and improve the performance. There's a continual push to introduce more and more electronics and capabilities in these systems so that our radar systems can detect threats from further away, so that our soldiers are able to have video feeds from live video feeds in the battle scene, and continuously to improve the technology. But for that requirement, power packages need to shrink in size. So the challenge that GaN can meet is that GaN is a disrupting technology, and it can help to meet that challenge of the continuous improvement in size, weight, and power. And Maincomp is leading that challenge with commercialization through the introduction recently of a 90 watt, a 50 watt, and a 15 watt GaN in plastic package. We have shown that this is a very reliable technology, and furthermore, with our rich heritage of 60 years with working with customers in these market segments, we can really help our customers to utilize this new technology in their new systems and meet their challenges. So, in regards to the GaN technology and the opportunity, it is the fastest growing segment of a $1.3 billion RF power transistor market, and is expected to capture 25% of the overall RF power market by 2016. So it's an incredibly important technology. And aerospace and defense is the segment that is most benefiting from it, simply because it is the market segment that requires the most optimum performance levels from semiconductor technologies. Now, I'd like to talk about an example of one of these segments, and that's air traffic control. Currently, most air traffic control systems utilize silicon bipolar power transistors, which are built into a pallet. And here's an example of an 800 watt peak single stage L-band pallet. Now, the next generation of radar systems, particularly phased array radar systems, cannot operate with such large power solutions. They need to be much smaller, they need to weigh less, particularly if they're used in an airborne application, while they need to maintain optimal performance and reliability. So the first stage is moving from silicon bipolar to gallium nitride allows for improved ruggedness, improved efficiency, and improved power density. So there's a significant improvement simply by moving from silicon bipolar to gallium nitride. But the true paradigm shift occurs when you use a commercial style packaging with gallium nitride to produce something that is completely different. And we have just released, Maincomp has just released a family of GaN in plastic power transistors that are built in a 3x6mm DFN package. So if you take your little pinky finger and you look at your fingernail, that's about the size of the package. And it's very hard to see here, but this is the size of the package here, 3x6mm. It's smaller than your pinky fingernail, and we're achieving 90 watts of output power, peak output power from a plastic package. But the benefit isn't only in terms of the small size. There's a significant benefit in the manufacturing process, where we're utilizing many, many years of commercial practices that use automatic processes such as automatic die placement, die attach, wire bonding, the die coat dispensing method, overmold. So this really results in a true commercial solution. And furthermore, not only is the package itself using a commercial practice, but it can then be implemented in a surface mount technology using a standard Rogers type material. There is no cutouts, there are no coins, there's no flange, there's no screws. It uses standard reflow process for your entire solution. So it's a completely different paradigm in terms of power solutions using gallium nitride in a commercial way. Some of the knowledge that we use is already developed in other industries, such as GaN, LED, and also the automotive industry. So it's not a risky approach. It's basically a commercial approach that's well understood with a high power, high performance semiconductor. In terms of reliability, we have done extensive tests in terms of high temperature operating lifetime tests for our gallium nitride technology. And we have shown that the reliability is excellent. For this 90 watt device here that's in a 3x6 millimeter package, the 90 watt output power with a pulse of 1 millisecond and 10% duty cycle only reaches a junction temperature of 113 degrees C. And this is observed junction temperature, which is our reference for all our measurements. The backplate temperature of the stage here is at 80 degrees C. Our own lifetime tests at 3 different junction temperatures have a predicted MTTF of 600 years at a junction temperature of 200 degrees C. So it's well below the capabilities of the gallium nitride technology. So in terms of thermal performance in a pulsed configuration, there is no question about its reliability. We release these parts right now, and you'll help my numbers if you place some orders today. So we have a 90 watt, a 50 watt, and a 15 watt device that are released. And we are now sampling a 5 watt part in the SOT 89 package. The 5 watt part can be operated up to CW duty cycle, as well as a 10 watt part we're in the process of developing that can also operate up to CW. That's not where we're stopping. In terms of the future directions of this technology, GaN in plastic with surface mount assembly can lead to other benefits. And here is an example of what we've done. And these will also be standard products. This is an L-band and an S-band module. And it's hard to see here how big those are. Those are 14 millimeters by 24 millimeters. But here's to give you an example of actually how large these truly are. And these are fully matched, 2-stage GaN module solutions. These use just standard reflow surface mount technology, and they can simply drop into the customer's board, and there is no manual assembly required. So it's a very easy and elegant solution for multiple applications, such as radar and communications, particularly for phased array. I also have, so basically you can see the huge advantage in space-saving power. Here's an example of a pallet based upon the standard flange type package, which uses up a lot of space. The power combining network is much larger. You need to have hybrids to combine the power, and that's only single stage. So there's far more functionality in being able to operate one of these devices using lumped element matching in a very simple, fully matched 50 ohm module. And I do have one last slide here that shows some of these results. This is 100 watts, and you can see here the left axis is in dBm. So at 50 dBm, that blue curve has a solid 100 watts across a wide range of input powers. The efficiency here is over 60%. Another key advantage of this technology is that the buffer, driver amplifier, and the power amplifier are designed to accommodate a wide range of input powers, because customers have to usually deal with a large variation in input powers, and over 5 dB of input power, we're achieving 100 watts of output power, 32 dB of power gain, 62% efficiency, and this is measured at 300 microseconds and 10% duty cycle. And this will be a standard product we offer for L and S band. So finally, to summarize the talk today, we spoke about the gallium nitride landscape and how this disruptive technology can lead to improvements in size, weight, and power for our customers, how those demands can be further enabled through MACOM's commercialization of GaN and release of GaN in plastic packages, and finally how future products that MACOM is developing can further enable customers to meet the challenges for their system requirements. So I thank you all for attending the talk. And if you have any further questions, please don't hesitate to ask me or visit our booth at 9:30. So really appreciate your time.